Okay, we still use the same example. We just use this one to introduce the scaling clause part. We know that in recentering, in addition to the ID data, we need another data type, is the PCM data. We can then load that data target from tools, recentering, import targets, and select the location of the PCM data as a Excel file. We can then add it to, we can then load it from here. In this example, I have already loaded, so I don't want to load it then. And then I can show you the how the data table looks like. It basically defines all the PCM data for different targets. As you can see, the device name, the instance name, and then the different PCM target. And then there's also a configuration table. It defines the PCM target related to which FOM used, which we defined in the ICCAP. So, for example, the ION, it is the ID in the FOM target, and you can define the error function, those error limits, unit, like this. And when we have defined, when we have load those targets, we can go to scaling clause again. And you can see from for the FOM part, we have those new targets begin with PCM, and also we go to the diagram part. We can see there are some new scaling clause here. Use the PCM target, same as the parameter target part. And we can show example repeating, and if we display it, you can see there's a typical value of the data points and the minimum value, max value as well. After we have defined those PCM target true and false, then we can use those clause in the extraction flow. For example, this step 3 is an optimization step. It is there are 3 PCM targets true used here, and you can also edit the step to add new false. For example, you can also add a VT. There is already VT lin, ID lin, ION. You can add one more VT set here and apply. That it would be added from to here, and then you can add the parameters to tune this step for you. Just want to show a very simple mobility example here. You can add this parameter to the parameter table. It's already here. Then you can use this tuner to tune the model. In the recentering process, we always want the error table to monitor the readout. So we can open the error summary from here. And you can have this error table. You can show the false and the error table at the same time, and then to tune your parameters. The tuning is getting better now, and when we update this table, you can see the error is getting much smaller now. And this recentering function actually can be used for corner thinking as well. We can take a look at how the circuit looks like. In the beginning part, we can see there are some corner keys on here. The 0 is the typical corner, and there's case 2, case 3, 0, 4, 1. So it's basically the 5 different corners: TT, FF, SS, FS, and SF. So after you define it properly, you can use it for corner taking as well. From the tools recentering enable corners, you can then enable the corner simulation on those plots. The corner model will appear on the plots as well. So this function can not only be used for recentering, it can be used for corner thinking as well.